Hello, welcome back to BlenderSushi live noding. I will do a quick one. It's basically a simple classic old problem to create a double helix for the DNA. I'm gonna do this using sphere chalk, and the setup looks something like this. So I tidy up the setup a couple of times. I try to make this a couple of times, and then I think this is the most kind of tidy setup. So the one node that's responsible for this is the this guy, vector polar input. The rest of them is just for decorations, but this guy does everything. Just this part of rho, phi, and the z can be just a little bit confusing, but I'll try to do it from scratch now, and we'll try to do it as fast as I can. There's a few trick you can do with that vector polar. Actually, there's quite a lot, but it's a trial and error thing. And once you understand how it works, then it's much easier to recreate a lot of structure. So this is double helix demo 001. Sphere chalks, create node 3. It's gonna have this. First of all, I will just create a vector polar input, and always viewer draw, and we have the single points there, and we're gonna use range float. From this guy to that guy, maybe at first, if you use it at the first time, it's kind of confusing because you're not quite sure, okay, what should I start with and what stop. And the rho and phi thing, if we kind of play around, I show you the basic of these nodes and in the previous video, but so I will do something that's similar, but this time I will use the start and using the phi, math phi, pi, actually pi. This is phi, this is pi. Let's see, we're gonna use radian. So from 0 to 360 degrees is 2 pi. So we need a math here. And so the stop is gonna be 2 pi. The count is 10 here. But how about the rest of this guy? The z, they're all gonna need a range float, and we're gonna use count. I believe after I do this a couple of times, I try to make it as simple as possible in this live noding. That's what I need, I think. 10, and then simply plug this into rho, phi, and the z. You see what happened just now? It's I plug it to the z, it goes up, okay, and I plug it to the phi, it goes now it's going in spiral because of the z, and then the rho actually control the start and the end of the, I don't know how to explain this. I think the center points position. Okay, the pi need to be 2 times pi, so now it's proper 360, I think. So if I start from there, I should end at the same place. Most of the time I think you want the rho to be the same number. Okay, now we have a spiral, one spiral. The cool thing about this guy is we can actually use it with edge adaptive. This is like an extra bonus, kind of like a detour from the helix thing. If we have like if we draw something using grease pencil and we want this spiral to go around it to make like a coil, like in a telephone cable or barbed wire. I think barbed wire, yeah. We can do that easily. Convert grease pencil into Bezier curve, and we should have Bezier curve somewhere. This guy, okay, let's put it in layer 1. Delete the grease pencil, and now we have this thing. Convert it to mesh. Now it's a mesh, but again, it's a lot, you know, a lot of points. We don't need that many points. We need to resample it. So objects in MK2, I'm gonna get the selection, vector interpolation, MK3, plug this a lot of points there, and then we're gonna resample it. Okay, basic stuff. I did it many times, so I'll do it really fast. I moved the curve just now, so I need to apply the matrix. This guy in. Okay, easy resampling, easy busy. Now with this guy as the kind of like a motion path, we can plug in our coil. I use the edge adaptive. So the donor and recipient. The donor will be that guy. So we need UV connection. Plug this. Let's check it out first. Okay, that's need to be edges. Okay, we have the spiral, like the element of spiral. We're gonna replace every edges here into that guy. So this is gonna be the donor, and this guy is gonna be the recipient, like so. Edges. Is it working? Should be working. Okay, I forgot. I need to plug this into the viewer. Okay, so yeah, something that looks like a barbed wire or a coil. Telephone cable. Oh, there's a cyclic. What's going on there? Oh, okay, that's the other edges. No, I can bake that, and then this guy is our coil. Skin modifier. But of course, you notice that it's we need to remove double in order for this guys to be like a single one objects connected to each other. We can adjust the resolution. Is that a step? What's the resolution? Is it this guy? No. The resolution is actually come from the pi. So more pi, it's gonna coil more. Well, actually the resolution should be also affected by this guy. Or I should switch to step. Start count step. Start step count. Got a little bit confused right there. Anyway, let's get back. Go back to our helix problem. Forget about the coil. Maybe that's for some other time, or just a bonus thing. So back to the coil. We need to basically, with double helix we have like a spiral, but we multiply it by 2. and so one spiral maybe goes a little bit offset than the others, and then it's combined together, and then by doing that we have the helix. So we need two of this guy. We can leave this, leave them as it is. I have a feeling that I might forget something here. So we have the pi. How do we control the resolutions? Maybe the start need to be adjusted. Radian, degree, count. Maybe having less of this. Interesting. I forgot something. What I'll do is I'm gonna maybe load the cheat sheet, import my previous helix, spiritual polar helix, import, and wait a few seconds, and we have the final helix here. It seems to be connected to something. Okay, let's have a look at this guy. We don't need this for now. Let's compare. We don't need the matrix. Let's check. So we have UV connection and vector polar, cylinder radian, and UV connection. Alright. I'm actually using step up here. No, I'm using step for the Z. So I'm using steps for the Z. Cut here and start at 0. Yep, start at 0 and have control over the step. So yeah, this guy's kind of controlling the indeed that guy, the step will control the resolutions. Pi, multiply, range float, count. The number, I guess the number also affected. Aha, I forgot. Okay, the number is controlling the resolutions of the coil. I totally forgot about this. Maybe I should give it color. Color yellow for, normally I color it yellow for whatever value that's important. Okay, that's for the coil, of course. And then we have the step there. start step count. I actually can just use count here. Oh, maybe just leave it like that. But you might notice here already in the our cheat node, we can see the top one is simple. Start stop. Start stop. Okay. The top one for the row is pretty much like that, but the one I have for the pie is a little bit complex here. So we have the start and stop, and we have range float and another range float, and I have count of 2 for each one of them, and I have all these. That's actually because of, we need 2 curve. Basically, that's the reason we are doing it like that. So instead of a single multiplier, we need 2 range float plug into another range float. Let me do that real quick. So range float and range float. One for the start and the other one for the stop. And the count is 2. Okay, so we have 2. Currently it has, I think I can have 3, or it's kind of like the ring of the cylinder. So I have 2, one at the bottom, one at the top, but I want to turn them into spiral. So for that I need to offset the start and the stop using this pi, something like this. Start and the stop, start and the stop. Here's when I was kind of playing around with this and try to guess the number. It will make sense after a while. Basically, you need a number that's kind of perfectly offset the spiral, so it's creating helix. So because if I'm playing around with the number, you see it's controlling the top, it's controlling the bottom of that guy, and the other one also doing the same thing. The count will add more spiral to it, but it's just gonna be a little bit complex that way. We don't want it. We just wanna deal with this guy. Okay, we don't need that anymore. Let's just deal with this. We actually already get the helix already. It's just a number, you play around with it. Maybe it's just something like that. Should be pretty good. Oops, the step kind of making thing failed. I think the count should be the count actually. Yeah, the count controlling. So that's for the bottom and the top. If we want more of the helix, we need to multiply this more. Interesting. Probably the step, the start and the step. Yeah, create a float here and then plug this there, plug that in there. So that's kind of controlling the top bit. controlling the bottom bit, but how to control the spiral? It's actually this guy, see? Controlling the step, and that should control the spiral. Okay, I'm getting more. Yeah, I guess that's pretty much correct. There, that's the helix. Maybe it can be better if I tweak the number, but it's pretty close. That's okay. That's controlling the helix as well. Yeah. Okay, that's pretty good. I think we can work with that. Yeah. Maybe I don't need to combine these two. Oops. Blender just crashes. I think I saved it already. Reopen. It's okay. I save all the time actually. So this helix can be affected by many things. I think I just leave it like that. Can be better, but I'm gonna pause the gist anyway, this setup. Okay, what we can do next is to create the connector, and for that, currently we have, if I bake this, we have two of this guy. Okay, we just need to connect them together. How do we do that? It's actually very easy. We just use the same vector input, but we just use the V direction, and we should have the lines get connected. Is it the U or the V? Interesting. I was kind of hoping that they're gonna connect with each other. I'm gonna see the sheet once again. Sorry about that. This thing can be quite complex. Polar helix try. See here, I'm getting the result I wanted. So what's wrong with this guy? What's the deal, man? It's almost exactly the same. That's the U directions. That's the V directions edges. Cylinder, radian, yep. Range, float, slightly different. Integer, right. Range and float. Start and stop. This is count, and that's count as well. 2, 2, and then pi. Pi multiplied by, let's try this number. Wow, looks like I plugged in the wrong thing, so that's the pi that goes into the z. That's why. That's why. Okay, that's a lot better. Save file, save as, new file. Okay, that's a lot better. I was plugging the wrong thing, you know. The Z and the row should be pretty simple, but the one that's complicated, a little bit complicated, is the phi. The phi actually, this is actually more like kind of like offsetting the rotations. It should be simpler, but I think it takes a while to understand this. Okay, so now we can control the resolutions, all that working perfectly. We have our helix thing. Very nice, very nice. Okay, now the next thing we want to do is just to extend the edges. We have learned how to do this already. So that's our edges. What we need to do is just separate loose part. And now these guys are all separated, the edges. They're all separate, and then we can use scale, don't grass. Scale. Plug the vertices in there. The center should be vector interpolation mk3. Plug this one in there. Vertices, we want the center. So with vector interpolation, basically I'm getting the center of each edges, and I'm using the center to scale. It's becoming like the pivot. There you go. That's our helix. The color. Let's give a red color here. Maybe the line's too long. If it's helix too fat, it's because of the row. There you go. That's much better. Spiraling, two spiral goes around, connected to each other. That's basically it for this spiral helix thing. If I'm not wrong, if we just use polyline viewer and plug that in, and here maybe 0.02. Oops, too small. And use another one for the 2 polyline. I remember we can actually separate this 2 polyline. By separating the 2. Because we actually use, because of this count here, 2, we actually have 2 lines already, and we just need to separate it using list item. Plug this one in there, plug that one, level 1, plug this in. The name should be different. One more for the other guy. Item number 1. Alpha 3. There you go. That's the DNA. Takes a while. A little bit confusing sometimes. But once you have it, you have it. You know, you can just save it. This is the double helix proper one. Gonna export it out. Export polar helix. There you go. Our DNA helix, double helix, created using Spreadshot. It's all rather basics, but because we use the node and everything in one go, if you want more resolution or less resolution, you can just adjust it here. It should update properly. Maybe I need to just update it in the timeline. So maybe set it to 100. See, it's updating. And set it to 150. More resolutions, and then we can adjust also how tall it is. The only one thing that's kind of missing is the way to put the DNA strand into path. Okay, that's I showed you earlier in the video, in the live noding video here in this episode, that we can kind of take the element and then use edge adaptive to replace all the edges of this motion path into this guy. But there must be a better way. Otherwise, you can use Blender own curve modifiers just to do the path thing. Just should I show it? Maybe I think you know already how to do it, so I'm not gonna show that. So anyway, this is a double helix. If you convert this into a mesh and then use and you just draw a curve that goes whatever, and use a curve modifier, it will bend. It will bend this guy to match it. Okay, that's one way to do it. Okay, hopefully this live noding video is useful. I guess I'll see you in the next video. Thanks again for tuning in. If you have any question, please leave in the comments down below. Okay, I'll see you in the next video.